You know, for what feels like forever, quantum computing has been that thing that's always just around the corner. Something you'd see in a headline, but never something you'd actually put in a project plan. It was basically locked away in a lab, way too fragile, way too abstract for the real world. Well, guess what? That just changed. That barrier just came crashing down, and it happened in a way that I don't think anyone really saw coming.
So, to really get what just happened, we have to start with this question. Who did we think was winning the quantum race? Because when I ask that, your mind probably jumps to a very, very familiar story.
Right. The narrative we all know is this big hardware arms race. We hear all about tech giants like IBM and Google, and the whole competition is framed around qubit counts and error correction. It's all about who can build the biggest, baddest, most stable quantum processor.
But here's the thing. The source material for today's explainer makes a really powerful point. The real bottleneck was never the hardware. It was the access model. Quantum computing has been this cloud-only thing, proprietary, slow, and just totally impractical for any real business with serious data security concerns.
So, if the game is suddenly changing, but it's not because someone unveiled a new chip with a gazillion qubits, what on earth just happened?
The breakthrough wasn't hardware. It was software, an operating system. And this is the development that quietly but definitively took quantum computing out of the lab and made it a real thing we have to think about for the very first time.
So let's meet the game changer, Origin Pilot V4.0, which comes from China's Origin Quantum. The keywords you need to see here are local, production-grade deployment. This is not some research tool for a PhD student. This is an OS designed to run on premises, in your environment.
So what does this thing actually do? Well, think of it as the soft heart of the whole system. It's the translator. It bridges that super sensitive, volatile quantum hardware with the stable classic computers we all know and love. And get this, it's hardware agnostic. It doesn't care if you plug it into a superconducting machine or an ion trap machine. Its whole job is to wrangle all the mind-bendingly difficult physics so that your developers don't have to. It turns quantum into just another manageable resource.
And that brings us to the real earthquake here. It's a total shift in the architecture. We're talking about changing the entire model for how we even get access to quantum power. Let's break down what that looks like.
So let's put these side by side. On one hand, you've got the model we're all used to, the Western, cloud-locked approach. You access everything through someone else's proprietary platform. That means you're stuck with their latency, their rules, their data governance. But now, look at the other side. This is the new on-premises model from Origin Pilot. It runs right there with you. It completely shatters that cloud dependency. It doesn't care what hardware you use. And this is the big one. For anyone in a regulated industry, it solves that whole data sovereignty headache in one fell swoop.
Okay. A new OS is out. Big deal, right? Why does this actually matter to you, a data engineer, like right now? Well, let's unpack the 3 immediate implications for the work you do every day. First off, those hybrid pipelines, the ones that mix quantum and classical computing, they're not just theory anymore. They are now a real architectural choice you can start thinking about. Second, data sovereignty gets this huge unlock. If you're in finance, defense, pharma, you now have a credible on-prem way to get into quantum. And third, this totally reframes the race. The real competitive lead might not be in the hardware after all, but in the software architecture that actually makes it usable.
This quote from the source article just nails it. Shipping a real production-grade OS that people can deploy themselves, that's not just another little step in the hardware race. This is a totally different kind of advantage. It is an architectural lead, and that creates a real, tangible advantage in usability and access today.
So, with this new reality, what do you actually need to do? It's really time to go from just watching this stuff from the sidelines to actually getting ready. So let's build a concrete, actionable plan.
The general consensus is that most data engineering teams have about a 3 to 5 year window before quantum becomes something you have to actively make decisions about. And in our world, let's be honest, that's right around the corner. The prep work for those future projects, it has to start now.
So what does this mean for your team? Let's make it super practical. Here are 3 things you can do. 1. Shift your mindset. This is the big one. Stop thinking of quantum as a science experiment. Start treating it like a real architecture problem, just like you would a new database. 2. Start paying close attention. Watch for those hybrid workflow use cases that are going to start popping up in your industry. And 3, it's time to take another look at your data. Seriously, re-audit your whole data sovereignty strategy, because having a real on-prem option completely changes the game.
I think this quote just perfectly sums up everything we've talked about.
The era of just passively watching from the sidelines, well, it's over. Quantum computing is now an infrastructure topic, something that's designed to plug right into the kind of hybrid environments that teams like yours are already building.
The big takeaway here is that the entire conversation has changed. The lab doors have been kicked wide open, and quantum is finally stepping out into the real world. So the only question left is, are you paying attention?